When you touch an object and it feels warm or cold, what is that really telling you about the object? Here I have a metal hard drive and a book, and I'm going to ask people to compare their temperatures. Which one do you think will feel warmer, the book or the hard drive?
The temperatures?
Yeah, tell me if one is hotter or colder, or if they're the same temperature. How do they feel?
This is slightly cooler than this one.
Yeah. Oh, that's warmer. Yeah, way warmer.
Yeah, agreed.
I'd say the hard drive is a lot colder than the book. I don't know, because the book's got more knowledge.
Why do you think that is?
Metal's normally a little bit chillier if you leave it in a colder temperature.
Well, what if I said that they're both at the same temperature? What would you say?
So you're lying.
But really?
I think you're lying, yeah.
Oh, jeez. Well, maybe the way I could prove it is I have an infrared thermometer. What do you think we're going to see?
I think science might be able to answer that, and I'm not a scientist.
Make a prediction for me.
I still think that's cool, though.
Would you bet me money?
I don't, because I don't have any cash, so yeah.
Let's measure the temperature of the book.
Okay.
What do you see?
19.0.
Okay. We measure the temperature of that.
19.0. All right, well, now I believe you.
I'm trying to actually figure it out, trying to figure out why they would be the same temperature. They don't feel the same temperature, though.
So why does that feel colder if they're basically the same temperature?
Good one. You got the answer?
Well, I'm coming to you guys for answers.
We're creatives, not intellectuals.
Well, create an answer for me.
I'm not a scientist. Come on, you tell me.
Well, I'll try to answer that question with another little experiment. Here is an aluminium block and
Ooh, nice and cold.
a plastic block.
Yeah.
How do their temperatures compare?
Completely different. Completely different.
Much colder.
Yeah.
Yeah?
Yeah, this actually feels colder.
Let's take this to the next level. I'm gonna put an ice cube on both plates. What are we gonna see?
Well, I'm guessing it would stay solid on this one and melt on this one.
So it's going to melt on the plastic but stay solid on the aluminium.
Yes, but maybe I'm wrong.
That one will melt more quickly than on the aluminium block.
You would think so. I mean, they're colder.
Yeah, because it's cold.
Let's
And
actually...
I think they're going to go the same.
All right, so we put an ice cube on each of those blocks.
Wow.
What are you seeing?
Well, it is melting a lot quicker on the aluminium.
I got it melting.
This is melting quicker than that one, even though this is aluminium, that's plastic.
So which one felt colder?
That
This
one.
How does that make any sense?
I have no idea, you know.
Could aluminium be bad for the environment?
How would aluminium be bad for the environment?
Well, it's thawing out the ice a lot quicker, isn't it?
So you want the answer?
Yes, please, please.
It's about thermal conductivity, right? The rate at which heat is transferred from one object to another. So when you felt these blocks originally, I know this one felt a lot colder.
Yeah.
But you know from the other example we did that they must both be at the same temperature.
True.
Because they've both been outside for a
Yeah.
while. We see that the aluminium block is melting the ice faster than the plastic block because it's conducting the heat to the ice cube faster.
Okay.
With the plastic block, it's a worse thermal conductor, so heat is being transferred less quickly to this ice block, and so it's staying ice.
Okay. I believe you.
Make sense?
Yes, definitely.
You know, in our first example, the hard drive felt colder even though it was at the same temperature roughly as the book. And that's because the aluminium conducts heat away from your hand faster than the book conducts heat away from your hand.
Sure, that seems logical.
Which makes the hard drive feel colder,
Yeah.
and the book feel warmer.
Yes.
So when you touch something, you don't actually feel temperature. You feel the rate at which heat is conducted either towards or away from you. Think about this next time you hop out of the shower in winter. It's much nicer to stand on the bath mat than on the tile beside it. Not because the bath mat is warmer, but because it conducts heat less quickly away from you.